All right, so in this video, we are going to cover a lot of short questions. Basically, I'm going to go through a practice exam and I'm going to do all the really short answer questions, basically 1 mark and 2 mark questions. So it's going to be a lot of quick questions in this, and you should know all of these before going into your advanced functions final exam. So with question number 8 on this practice exam, which is converting from exponential form to log form and vice versa. The first question is z equals m to the exponent of n, and we need to convert this into log form. So if I want to convert this into log form, I have to log both sides, but I have to make sure the base of my log is the same as the base of my exponent. So I'm going to do log m base on both sides. This is what it's going to look like. And then log m just cancel, and you're just left with whatever is the exponent. You're going to bring it down. So log with m to the base z equals n is my log form for this equation. Second question, we're given log form, and we need to convert it to exponential form. So it's the backward steps. So if you have a log, you need to do an exponent to both sides, and the exponent has to have the same base as the base of the log. So I'm going to do 3 to the power of both sides. So 3 to the power of 7 equals 3 to the power of log 32187. And then 3 and log base 3 just cancel, and you're left with 3 to the power of 7 equals to 2187. And now this is exponential form over here. So as you can see, we've just moved this base back and forth. We've got rid of the log, and same thing over here. The base just moves back and forth. This m moves over there. But I've shown the complete steps so you understand it. So the next example, which is 4096 equals 8 to the power of 4. We're going to do log base 8 on both sides. Then this cancels. So log 8 4096 equals 4. This is the log form. And last one is in log form. A equals log x to the power of y. You convert to exponential form. So I'm going to do x to the power of both sides. This is going to cancel. So I just have x to the power of a equals y. Okay, that's the first question there, number 8. Next, let's do some pH questions. So it tells us that the pH, and this is question number 14 in the paper, pH equals 2.0 of lemon juice, and we need to find the hydrogen ion concentration. So this is very simple. You just have to make sure you know the formula. pH equals negative log H plus, where H plus represents the hydrogen ion concentration. So we're given the pH equals to 2. We need to find the hydrogen ion concentration. So we need to isolate for H plus. I'm going to divide both sides by -1 to begin with to get rid of this negative. So -2 equals to log H plus. And then we're going to get rid of the log. So to get rid of the log, I have to do 10 to the power of both sides. So when I get rid of the log, I'll write it in the same step. I'm doing 10 to the power of both sides. That's going to cancel. I'm just left with 10 to the power of -2 equals H plus. Just remember, when you're getting rid of a log and you move the other side, it becomes 10 to the power. And that is my final answer. This is basically in molecules per liter. That's the unit. You'll generally have an answer which has 10 to the power of a negative exponent for calculating H plus, or basically like a decimal value, which is the same thing. Next question, question number 15, pretty similar question. We're now given that the hydrogen ion concentration, basically H plus, is 0.0038, and we need to calculate the pH. So same formula, pH equals negative log H plus. And we know that the hydrogen ion concentration is 0.0038, and then we just type this in our calculator. So negative log 0.0038 is just 2.42. So the pH is approximately 2.42. All right, next question is number 16, and number 16 gives us an arc length of 2 meters, and the angle subtended by the arc, called theta, is 1.7 radians. You need to find the radius. So this is just using your arc length formula, where theta, which is the angle in between, is equal to arc length divided by radius. Arc length has to be in meters, and the radius also has to be in the same unit. And the theta has to be in radians. So if you're given degrees here, you got to convert to radians first. So in this question, we are given theta is 1.7 radians. It's already in radians, so no need to convert. A stands for the arc length, which is 2, and we need to calculate the radius, which is in the denominator. So now I'm going to just cross multiply these two. So R equals to 2 over 1.7. And 2 divided by 1.7 is just approximately 1.18. The unit's going to be the same as arc length. So if that's meters, this is also going to be meters. Next question is pretty similar, but now this is question number 17. We are given that the arc length is 18 centimeters and the radius is 9 centimeters, and we need to find the angle, which is again pretty simple. We're using the same formula. Theta equals to A over R, which is just 18 over 9, which is just 2 radians. So very, very simple. You just need to know the formula and how to apply it, and make sure that your angle is in radians. If it's in degrees, convert from degrees to radians, which ironically is going to be the next question, conversion from radians to degrees and degrees to radians. So question number 18, we are given pi over 6 radians, and we need to convert this to degrees. So when converting from radians to degrees, we multiply by 180 over pi. I'll write it down over here. Radians to degrees, we multiply by 180 over pi. And by converting from degrees to radians, the opposite, we multiply by pi over 180. So converting from radians to degrees here, I'm multiplying this. Pi and pi cancel. 180 divided by 6, that's just 30 degrees. So pi over 6 is the same as 30 degrees. So for the next one, which is 2 pi over 3, pi and pi cancel. 3 and that's going to become 60, because 180 divided by 3 is 60, and 2 times 60 is 120 degrees. So 2 pi over 3 is the same as 120 degrees. Next question, we're converting 135 degrees into radians. So now I'm going to multiply by pi over 180. And you can just do this in the calculator. It'll automatically simplify 135 by 180. I know you can divide them both by 5, but there's probably other numbers. And that is true. You can divide it. It simplifies all the way down to 3 pi over 4. And next question over here is 300 degrees times pi over 180. So convert to radians. So again, I'll do this in the calculator. 300 times pi over 180 is 5 pi over 3 radians. So 300 degrees is the same as 5 pi over 3 radians. All right, next question here is question number 21, we have cos 4 pi over 9. And we need to write an equivalent expression in terms of this one over here. So what we want to do is we want to use our cast rule for this. Okay, in this question, we're actually given the angle. We know that the angle is 4 pi over 9. Now, 4 pi over 9 is slightly less than pi over 2 because 4 pi over 8 is the same as pi over 2. So 4 pi over 9 is slightly smaller than pi over 2. So it's going to be in this first quadrant over here. Okay, so I have cos of 4 pi over 9. I know that all my angles are positive, all my ratios are positive in this quadrant. So cos is definitely going to be positive here. The other quadrant that cos is positive in is down over here. Cos is positive in these two quadrants. This is also going to be 4 pi over 9. And then I want to find this full angle over here. So full circle is 2 pi. And then I'm going to subtract 4 pi over 9. So then I'm going to find out this whole principal angle through this second line over here. I'll draw the angle a bit better here. So this angle right there, that's what I'm finding, my principal angle. I'll do this in my calculator. 2 pi minus 4 pi over 9 is just 14 pi over 9. So I know cos is positive in these two quadrants. So cos 4 pi over 9 is the exact same as cos of 14 pi over 9. And these two are equivalent expressions. 22 is the same concept. We have sine pi over 55. We need to write an equivalent expression in that's the same as this. So again, I'm using my cast rule. Pi over 55 is an extremely tiny angle. It's going to be in the first quadrant. And sine is positive in A and this quadrant here. So if this is positive, it has to be the other positive one here for sine, which is pi over 55. And now I want to find this principal angle over here. So I know that a full half circle is pi. So I'm doing pi minus pi over 55, which is just 54 pi over 55. So sine of pi over 55 is the exact same as sine of 54 pi over 55. That covers this. Next question is going to be question number 27. In question number 27, we're given a sine function. It has an amplitude of 7. The period is pi. Phase shift is pi units right. And it has a reflection in the x-axis. And we need to write a formula for this equation. Again, there's multiple possible solutions, so I'll just do one solution over here. I'm going to start with y equals reflection of the x-axis means we need a negative. Then we put amplitude here, 7. Then we have sine because it's a sine function. Then we need to find the k value. So to find the k value, we're using our period. K equals to 2 pi over p, which is 2 pi over pi, which is just a k value of 2. So next goes my k value. Then I have a double bracket because I have a phase shift. Pi units right means it's x minus pi. And then in this question, they don't mention the equation of axis. So we're just going to assume it's 0. And we're not going to add anything over there. So that's the full equation over here. Next question is 27b. We have a cos function. and the amplitude is 12. The period is pi over 2, and the phase shift is 2 pi to the right. And we have a reflection in the y-axis. Again, there's no equation of axis here, so it's going to be 0. So if we have a reflection in the y-axis, remember the negative is going to be on the inside of the bracket, not the outside. I'm going to start with y equals, I'm going to put my amplitude first, 12. The cos function, so cos. And then we have a reflection in the y-axis, so the negative goes over here. So for a reflection on the x-axis, the negative is in front. Reflection on the y-axis, the negative is inside the bracket. We have a period of pi over 2, so I can calculate my k value. It's 2 pi divided by pi over 2. Pi and pi cancel, so that's 2 divided by 1 over 2, which is just 4. So we have a k value of 4. X, my phase shift is 2 pi units to the right, so x minus 2 pi. And there's no equation of axis, so that is my formula for this one. All right, so that probably concludes it. I can probably do an IROC question over here. So we have a function f of x equals, this is question 35. One of the last questions in the test, equals to x squared minus 9. And we have to determine whether the function has a maximum or minimum at the point x equals to 0. Now, this is kind of like an obvious question. We know that x squared minus 9 is just a quadratic function that looks like this, which means that x equals to 0 is going to be a minimum. But they want the calculations for us to prove this. And in order to prove this, we have to use IROC and the IROC method. So we have to prove that the slope before is negative and the slope after is positive. So what I'm going to do is I'm going to find f of negative 0.01. I'm going to use a h value of 0.01. Then I'll do f of 0. I'll do f of positive 0.01. So I'm going to sub in negative 0.01 into that equation. I'll just do it in my calculator. Get negative 8.9999. Make sure you take at least 4 decimal places here. F of 0 is just negative 9, and f of 0.01 is also negative 8.9999. Okay, so now I want to find the IROC before. So IROC is just, I'm going to do it for these 2 points over here. So y2 minus y1, negative 9 minus negative 8.9999 divided by x2 minus x1, so 0 minus negative 0.01. And if I calculate this, negative 9 plus 8.9999. Oh, that's a really small number. Negative 0.0001 divided by bottom is just going to be positive 0.01. And this is going to be negative 0.01. So we've already proved that the slope before is negative, going down before the point at x equals to 0. Now I got to prove that the slope after so my IROC, I'm going to do y2 minus y1. Now it's negative 8.9999 minus negative 9 over x2 minus x1. So 0.01 minus 0, which is just 0.0001. divided by 0.01, which is positive 0.01. So slope before is negative, the slope after is positive, and the slopes are really, really close to zero. So basically what's happening is we have a really flat negative slope, a really flat positive slope, and then this point is x equals to 0. So we know that this is definitely going to be a minimum over here. I'm using IROC, and again, you want to put your statement at the end of this problem in a test. Using IROC to prove that x equals to 0 is a minimum. That's concluded. That concludes this video. Not going to do any more questions. I think that should be pretty good.